All right, welcome back. Ready to dive back into the world of fine-tuning LLMs.
Absolutely. Let's do it.
Last time, we talked about LLMs being like Swiss Army knives, right?
Yeah.
So today we're opening up section 1 of the ultimate guide to fine-tuning LLMs to really figure out how to sharpen those blades for some really specific tasks.
This is where it gets exciting because we're going way back to those kind of clunky early chatbots to understand just how far these models have come and, why that makes fine-tuning so powerful.
Okay, so this section starts off talking about something called statistical language models, or SLMs. And I got to be honest, I kind of skimmed that part. Could you give me, like, the crash course version?
Okay, so imagine, trying to predict the next word in a sentence. That's what these SLMs are doing, but just based on, how often words tend to appear together. It's kind of like, basic autocorrect, but for, whole sentences.
Wow.
Good starting point, but pretty limited, right?
Yeah, that makes sense. So how do we go from predicting the after A to, these crazy, powerful LLMs that can write poems and code?
Neural networks, that's the big leap. Instead of just stats, neural language models, or NLMs, use these networks loosely inspired by how our brains work. So suddenly, it's not just about word frequency, but more about understanding, relationships and meaning between words.
So instead of a dictionary definition, it's like understanding the vibe of a word, like how it fits with the words around it.
Exactly. And one example the paper mentions is word2vec, which literally creates these maps of words based on their relationships. Think of it as a social network, but for vocabulary.
Huh.
So similar meanings, closer on the map.
Okay, that's pretty cool. NLMs definitely sound way smarter than SL.
Oh, for sure.
But then the paper takes us even further, right? Into the world of PLMs and LLMs. It's like alphabet soup over here.
Yeah. Think of NLMs as laying the groundwork, but then PLMs, or pre-trained language models, come along and basically devour every scrap of text data they can get their hands on. This pre-training is like giving them a crash course in, well, the entirety of written language.
So they're like those friends who've already read the entire syllabus before the first day of class.
Exactly.
Show-offs.
So models like GPT-2, BERT, those were early examples. And they kind of blew people away because suddenly they could actually do things like translate languages, summarize documents, all thanks to that massive pre-training.
Okay, so PLMs are like the overachievers of the language model world. But then we have LLMs, large language models, the rock stars.
Right.
What makes them different?
LLMs take that whole read everything approach to a whole other level. We're talking billions, even trillions of data points. So they're not just pre-trained, they're practically omniscient at this point. Think GPT-3, GPT-4, LaMDA. These are the models making headlines, right,
Yep.
for sounding so human.
That's incredible. But here's where it gets really interesting for me, and I bet for you listening too, it's fine-tuning. The paper defines it as taking that pre-trained LLM and tailoring it for a very specific job. It's like going from mass production to bespoke tailoring.
Exactly. You wouldn't teach someone to read all over again just because they wanted to learn, I don't know, astrophysics, right?
Mm-hmm.
Fine-tuning takes advantage of all that existing LLM knowledge, so you're not starting from scratch.
It's like having a head start in a race.
Right.
So instead of building a chatbot to answer any question imaginable, you could fine-tune it on, say, medical textbooks to make it an expert medical assistant.
There you go. And that's where the paper really emphasizes the why behind fine-tuning. It's not just about making these models better. It's about making them useful.
Mm-hmm.
We want LLMs that solve real-world problems. That's where fine-tuning comes in.
Right. It's kind of like, having all that knowledge is one thing, but being able to apply it, that's where fine-tuning really shines.
So it's about making them useful, not just impressive.
Okay, so fine-tuning unlocks that potential. But then the paper goes into this whole thing about RAG, and I got to be honest, I kind of got lost there. Can you, break that down for me?
Yeah, of course. So imagine you give an LLM access to this massive, external library. That's basically our RAG, or retrieval augmented generation in a nutshell. It's like having a research assistant who can pull up any book, any document ever written.
So instead of just relying on what it learned during pre-training, it can actually, access up-to-date info and even, expand its knowledge base.
Exactly. And here's the really cool part. Fine-tuning makes our RAG even more powerful. Because by tailoring the LLM to better understand and actually use that external information, it's like, giving that research assistant a PhD in information retrieval.
Whoa, okay. So we're talking LLMs that are not just knowledgeable, but incredibly efficient at actually accessing and applying that knowledge. That's a powerful combo. But I have to ask, How do you choose between fine-tuning and RAG? It's like choosing between two superpowers.
It is fascinating, right? The choice really often comes down to the specific problem you're trying to solve. Think of fine-tuning as giving the LLM specialized skills, while ARG is more like giving it access to a massive toolbox.
Okay, I like that. So if I need an LLM to write like Shakespeare, I'd fine-tune it on all of his works. But if I needed to, like give me the latest stock updates, ARG would be the way to go.
Exactly. And, the paper points out that ROG actually has a really unique advantage. It's less prone to what we call hallucinations.
Hallucination, are we talking like AI tripping out now?
Not literally, no. No,
Well,
no. It's when an LLM basically just makes stuff up. And here's the thing. It sounds really confident, but it's completely off base. Because ROG is grounded in that external data, it's less likely to go off the rails. It's like having a fact checker built in.
okay, so ARG kind of keeps things accurate, which makes sense, especially for things like, news updates or like actual research. I can see why that'd be super important.
Absolutely. But, choosing between fine-tuning and RAG, it's not always this black and white decision. Sometimes the best approach might involve using both.
The best of both worlds, huh? So we've covered a lot of ground here, from those early chatbots to like the power of fine-tuning to RAG. It's like we've zoomed through the history of LLMs and arrived at the cutting edge.
And that's just the tip of the iceberg. Because Section 1 also dives into what it calls the 7 stages of the LLM fine-tuning pipeline. It's like a roadmap for unlocking the full potential of these models, ready to see what goes on behind the scenes.
Ooh, yeah, I'm all ears. It's like we've talked about the why of fine-tuning, now we're getting into the how.
Yeah,
This is where it gets really interesting for anyone who wants to actually use LLMs to build something amazing.
absolutely. Think of it like baking a cake. You need the right ingredients, you need the right tools, and you need a good recipe to follow. That's what this pipeline provides.
Okay, I'm ready to put on my baker's hat. Let's start with stage 1, dataset preparation. Tell
Yeah.
me everything.
All right, so this is where we gather and prepare all of that data that our LLM is going to learn from during fine-tuning. Think of it as choosing the highest quality ingredients for our cake.
So no expired milk or like stale flour.
Exactly. We need fresh, relevant data that's really specific to the task we're fine-tuning for. The paper emphasizes having a clean, well-formatted data set that really clearly demonstrates the outcome you want.
So if I'm fine-tuning an LLM to write like catchy ad copy, I'd feed it a data set of like really successful ad campaigns.
You got it. The dataset should include examples of both the inputs and the outputs you want the LLM to learn. In this case, that'd be product descriptions and the corresponding really awesome ad copy.
Makes sense. But what if we accidentally include like some misleading or just like really bad ad copy in our data set? Would that mess things up?
Oh, absolutely. That's why data cleaning and reprocessing are so crucial in this stage. It's like washing and chopping our ingredients before we just toss them in the mixing bowl. We need to remove any errors, any inconsistencies, and even biases that could throw off our LLM's learning.
So data quality is key. We need to be as meticulous as a like Michelin star chef with these ingredients. What's next in our fine-tuning recipe?
Stage 2 is model initialization. Now that we've prepped our ingredients, we need to choose the right pan and preheat the oven.
So we're setting up the LLM for success.
Precisely. Model initialization involves selecting the appropriate pre-trained LLM for the task at hand and configuring its initial settings. It's kind of like, choosing a cake recipe that's actually well suited for our ingredients and our desired outcome.
So we're not like baking this cake from scratch. We're starting with a pre-made mix, but we might need to make some adjustments.
Exactly. We might need to adjust the learning rate, the batch size, or some other parameters to optimize that fine-tuning process for our specific data and, of course, the task we're working with.
It's starting to sound a bit technical. Is this where I need to like brush up on my coding skills?
Don't worry. There are actually a ton of tools and resources available that really simplify this entire process. The paper even mentions some popular libraries like Hugging Face Transformers and DeepSpeed. They provide pre-built functions and configurations specifically for fine-tuning. It's like having a high-tech oven that does most of the work for you.
Oh, thank goodness. I'm much more of a like follow the recipe kind of person when it comes to this stuff. Okay, so we've got our data, our model is primed and ready to go. What's next?
Stage 3, training environment setup. Now we're talking about the kitchen itself, making sure we've got all the right equipment and that everything is, clean and organized.
So like we need a good mixer, a spacious countertop, maybe even one of those fancy stand mixers with all the attachments.
Exactly. In the world of LLMs, this translates to having the necessary hardware and software infrastructure in place. So we might need powerful GPUs or TPUs to handle the computational demands of fine-tuning, along with the right software libraries and frameworks.
GPUs and TPUs.
Mm.
Are we like building a supercomputer now?
Yeah. Not quite. But these specialized processors, they're really essential for training these large language models efficiently. They're kind of like having a whole team of expert bakers all working in parallel to speed up the process.
Okay, so it's all about optimizing for like speed and efficiency. And I'm guessing the software is like having like the right measuring cups and mixing bowls.
Exactly. We need tools like CUDA, cuDNN, and, deep learning frameworks like TensorFlow and PyTorch to actually write and execute our fine-tuning code. The paper goes into a pretty good overview of all these tools and how they kind of fit into the bigger picture.
It's like we're building our dream kitchen, but for like fine-tuning LMs. But let's be honest, the real fun starts when we actually get to bake the cake, right?
Yeah.
Tell me about stage 4 fine-tuning.
This is where the magic happens. We take our prepped data, our initialized model, our optimized environment, and we hit that start button.
So it's like pouring the batter in the pan and sliding it into the oven.
Exactly. During fine-tuning, the LLM basically processes the data over and over, kind of like, adjusting its internal parameters to make fewer errors and get better at whatever specific task we're training it for.
So it's like the LLM is tasting the batter with each iteration, adjusting the ingredients until it gets that flavor just right.
I like that. That's a great way to put it. And just like with baking, we need to, keep an eye on the process to make sure everything's going as planned.
The paper mentions like monitoring the training loss. I imagine that's like checking if the cake is rising properly.
You got it. The training loss is basically a measure of how well the LLM is learning from that data. Ideally, we want to see it go down over time, which tells us the model is getting better at whatever task it's learning.
So a lower loss is like a perfectly risen cake, a sign that we're on the right track.
Exactly. And just like we might have to adjust the oven temperature or the baking time if our cake's not baking evenly, we might need to tweak things like hyperparameters or even the training data if that loss isn't decreasing like we expect it to.
Fine-tuning, it's like this delicate dance between art and science. We need the right ingredients, the right tools, and a little bit of intuition to guide the process.
It really is. And speaking of intuition, the next stage is where we put our taste buds to the test.
Ooh. Stage 5, evaluation and validation, bring on the taste test.
All right, so this is where we figure out how well our fine-tuned LLM actually performs on data it's never seen before, data it hasn't encountered during training. It's like taking our cake to a bake-off and letting the judges decide if it's truly delicious.
Okay, so we're looking for some honest feedback from, like, impartial judges. No biased taste testers allowed.
Exactly. We need to make sure our LLM can actually generalize its knowledge and perform well in real-world scenarios, not just on the data it was specifically trained on.
So how do we do that? Like, what kind of evaluation metrics are we using? Is there a Michelin guide for LLMs?
You bet there is. The paper outlines several key metrics we can use depending on the task. So, for example, if we're fine-tuning an LLM for text summarization, we might use metrics like Rouge or BLEU scores. These measure how well the LLM's summaries capture all the key information from the original text.
So it's like judging a cake on its presentation, its texture, and of course its taste.
Yeah.
We need to make sure it's appealing from all angles.
Exactly. And just like a really discerning judge might offer some constructive criticism, this evaluation process can help us spot any areas where our LLM might be falling short.
So you can go back to the recipe and, like, make some adjustments.
Exactly. Maybe we need to tweak those ingredients a bit, adjust the baking time, maybe even try a different oven. The evaluation phase helps us fine-tune our fine-tuning process.
It's like we're becoming master chefs of LLMs, constantly refining our techniques to create that perfect model. But once we're confident in our creation, it's time to, share it with the world, right?
Absolutely. Stage 6 is deployment, the moment we've all been waiting for.
Let's serve this cake. But seriously, what does deploying an LLM actually entail?
So deployment involves making our fine-tuned LLM accessible to users, or maybe integrating it into applications where it can really work its magic.
So it's like setting up a bakery and showcasing our prize-winning cake.
Precisely. We might deploy our LLM as an API that other applications can access, or, integrate it into a chatbot or a virtual assistant. We could even embed it into a website or a mobile app.
So our LLM is out there, ready to dazzle everyone with its newfound skills. But our work isn't over yet, is it?
You're right. Just like a bakery needs to, maintain its ovens and keep its kitchen spotless, stage 7, monitoring and maintenance, is crucial for making sure our LLM continues to perform at its best.
Okay, so we got to keep a close eye on our LLM, make sure it's not getting into any trouble.
Exactly. Monitoring involves tracking key metrics. Things like, inference speed, accuracy, user feedback, all to try and catch any potential issues or areas where we might need to improve things.
So it's like checking the cake for staleness, making sure the frosting isn't melting, seeing if our customers have any suggestions.
Precisely. We want to make sure our LLM stays fresh, it stays relevant, and continues to, delight our users.
Monitoring and maintenance sounds essential for long-term success. It's like the difference between a, flash-in-the-pan bakery and one that's cherished for generations.
That's a perfect analogy. And that brings us to the end of the 7 stages of the LLM fine-tuning pipeline.
This has been incredible. From understanding the building blocks of LLMs to, mastering the art of fine-tuning, it's been a journey.
And we've only just scratched the surface. There's so much more to explore.
I'm ready to, roll up my sleeves and get my hands dirty with the details.
That's the spirit.
Mhm.
Let's break down each stage of that fine-tuning pipeline, starting with dataset preparation. Remember, this is where we gather and prep all that data our LLM's going to learn from. It's the foundation for, everything else.
Okay, so no cutting corners on data quality. What are the key steps to getting this data ready for our LLM feast?
So the paper breaks it down into 4 key steps: data collection, data preprocessing and formatting, handling data imbalance, and splitting the data set. Think of it like, at the beginning, sourcing the finest ingredients. Then you meticulously clean and prep them, make sure you've got a balanced recipe, and then portion everything out for the different stages of cooking.
Okay, I'm following the culinary analogy. Let's start with data collection. Where do we even find the, raw materials for training an LLM?
Data collection is kind of like sourcing ingredients from different markets, specialty stores. We might grab text from websites, social media, books, research papers, code repositories, you name it. The key is choosing sources that really align with whatever task we want our LLM to be awesome at.
So if we're training an LLM to be like a chatbot for a tech support company, we'd want to feed it things like manuals, those troubleshooting forums, maybe even transcripts of, past support conversations.
Exactly. The more relevant, the more diverse that data is, the better equipped our LLM is going to be to handle those real-world situations. And just like a good chef carefully selects the, freshest ingredients, we need to make sure our data is top-notch, free from any errors or inconsistencies. That's where that data preprocessing and formatting step comes in.
It's like, washing, peeling, chopping our veggies before we just toss them in the pot. Got to remove any impurities and make sure everything's the right size and shape right.
Precisely. This step involves cleaning the data, handling any missing values, and getting it all formatted in a way that our LLM can digest. It's like translating our recipe into a language our LLM chef can actually interpret.
Okay, makes sense.
And we might use techniques like tokenization, stemming, stop word removal, that kind of thing, to standardize all that text and make it easier for our LLM to actually process.
Okay, so we've sourced our ingredients, we've prepped them carefully. What's next?
Now, imagine you're making a cake, right? You wouldn't want a cake that's all sugar and no flour. That's where handling data imbalance comes in.
So we need to make sure our data set represents the different aspects of the task we're training for in a balanced way.
Exactly. If we're training an LLM to do something like classify movie reviews as positive or negative, but our data set's mostly positive reviews, well, our LLM might end up kind of biased towards that positive sentiment. To avoid that, we might need to either, gather more negative reviews or use techniques like oversampling or undersampling to balance things out.
It's like adjusting the proportions of the ingredients in our recipe just to make sure the flavors are all balanced and nothing's overpowering the rest.
You got it. And once we have a nice balanced and pre-processed data set, that final step in data set preparation is splitting the data set.
So we're dividing our culinary masterpiece into portions for different purposes.
You got it. We typically split it into 3 parts: a training set, a validation set, and a test set. The training set is like the main batch of our recipe. That's what we use to train the LLM. The validation set is kind of like a small paste test we do along the way just to see how our recipe's coming along. And the test set, that's like saving a slice of that final cake to, wow our guests at the very end.
I love how you've managed to weave in this culinary theme throughout this whole process. It makes even the really technical parts of fine-tuning seem kind of approachable.
Oh, just like a good meal. A well-trained LLM is something to be savored. But unlike that delicious cake, building a fine-tuned LLM takes patience, precision, and a deep, deep understanding of this entire process.
And speaking of the process, we've only just begun to explore this exciting world of fine-tuning LLMs. But sadly, that's all the time we have for today.
But don't worry, we'll be back next time to dive even deeper into the remaining stages.
Until then, keep those brains buzzing and those appetites for knowledge insatiable. We'll see you on the next deep dive.